the x-axis with its displacement at time t given by x equal to 6t square minus t raised to the power 3 plus 1, where x is measured in meters and t in seconds. Find the velocity and acceleration of p at time t. Find the times at which p is at rest and find its position at these times. Dear students, in this problem differentiation is the main tool. Okay, we know that first derivative of displacement is velocity and second derivative is acceleration. Okay, so on the basis of this concept we start our problem solution in a regular manner. Okay, displacement at time t is x equal to 6t square minus t raised to power 3 plus 1. Okay, this is given in this statement. Okay, this implies that, as I have already mentioned, that first derivative of displacement is velocity while second derivative of displacement is acceleration, or in other words first derivative of velocity is acceleration. Okay, so we are making use of this technique only, nothing else. Okay, x is equal to this, then v will be equal to x dash, because first derivative is also sometimes denoted by dash and second derivative by double dash. Okay, v equal to x dash equal to dx by dt is equal to, dear students, here 6t square means 12t, because 2 will be multiplied with 6 and power of t will be reduced by 1 and hence 12t minus t raised to the power 3. 3 will become with t cube while its power will be reduced by 1. Okay, minus 3t square meter per second. We know that unit of velocity is unit of speed or meter per second, while unit of acceleration or meter per second square. Then this implies that acceleration a equal to v dash. Dear students, acceleration a is equal to v dash is equal to x double dash. We can also write it as x double dash. Okay, acceleration, this implies that acceleration is equal to v dash equal to x double dash equal to dv by dt. Now 12 differentiation of 12t will be simply 12, while differentiation of minus 3t square will be 6t, because this 2 will be multiplied with this 3 and its power will be reduced by 1. Okay, so 12 minus 6t meter per second square. Okay, as I have already mentioned that units of velocity are meter per second, while units of acceleration are meter per second square. Dear students, putting v equal to 0 gives, where put v equal to 0, v equal to 0 this is v, and now we are going to put it equal to 0. Okay, putting v equal to 0 gives 12t minus 3t equal to 0. This implies that we can take 3t as common from these two factors. So 3t common, 4 minus t equal to 0. This implies that either 3t equal to 0 or 4 minus t is equal to 0, and hence t gets two values here. Okay, one is t equal to 0 second and other is t equal to 4 second. Okay, because this product is equal to 0, it implies that either this is equal to 0 or this is equal to 0, or both can also be equal to 0. Now, first we consider the case when t is equal to 0 second. Okay, at t equal to 0 second, x equal to, we will put value of t equal to 0, and hence x will become 1. X is becoming 1, and we know that unit of displacement is meter, so x will be 1 meter. And when we will consider t equal to 4 seconds, then we will put time t equal to 4 seconds in that expression, and we will get x equal to 33, and we know that unit of displacement are meter, and hence x will be equal to 33 meter. Okay, this was what we were required to do. Okay, this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.